Hi there. Welcome to this tutorial where I'll be explaining how you can help us to bring Ivy into alignment with the Array API standard. First of all, I'll explain what the Array API standard is. Then I'll go through what the process looks like for making a pull request and how you can actually flag to others in the community which function you're going to work on, and actually then go through the steps to get the pull request accepted and merged. And then finally, I'll give a bit more of an explanation on the videos that are following in this series as well. So without further ado, let's get our browser open and let's go check out the standard. So it's the Consortium for Array API Standards, something like this. Okay. So actually, let's just go to their homepage and then the API specification. Okay, and then here we are, and this is the Array API. So you can see all of the methods, all of the creation functions, the broadcasting functions, and so on. Each of these has their own subpage that gives a bit of a background, an overview, and an explanation. And then also, although broadcasting is a bit different, let's look at element-wise. Here we go. So this is kind of a home page explaining the element-wise functions, then with links to each of the separate function standards, which you can see here. It gives you the special cases, the parameters, the returns, important notes, and everything you need in order to understand what the standard is like limiting the function to, or constraining the behavior to be, is all defined in these files, on these pages, I should say. So with regards to writing unit tests for Ivy, in order to get each of the Ivy functions adhering to the standard, broadly speaking, we need to make sure that syntax is the same so that we have the same name. And I'll take another, let's take, cos is very simple. So we need to make sure that the function in Ivy is called cos. We need to make sure that the argument is called x, and then we need to make sure that everything explained here is adhered to in the unit test. And in this case, it's quite simple, but for other examples, there might be some default behavior when a parameter or a shape or an axis isn't specified that then, for example, might perform a reduction over all of the axes and so on. So we need to make sure that we thoroughly test all of these corner cases. Well, not corner cases as such, but we need to make sure we test all of these different input types to the function. So this is kind of what the standard looks like when you're looking through the files. A quick note on why we want to adhere to the standard. So obviously there's lots of frameworks out there. There's PyTorch, there's TensorFlow, there's MXNet, there's NumPy, there's JAX, and there's many others. There's Chainer, and I could keep listing them. And all of these have slightly different syntax, particularly at the functional API. What we don't want to do is become another incompatible syntax that is different to all of those and is yet another set of behaviors thrown into the mix. And we really applaud the work that the guys and gals working on the Array API standard, we applaud their efforts, and this is a very, very important thing in the machine learning community to bring things closer towards unification. So this is why at Ivy we want to adhere to this standard, because we long-term would like other frameworks to also kind of slowly, incrementally conform and become more similar than they are different. And we think that this Array API standard is the best place to do this, and it's the biggest effort to do this standardization that exists. So this is why we want to adhere to the standard, and this is what the standard looks like. So now let's talk a little bit about the process of getting Python to adhere to the standard. So let's go to the website. Let's go to code. And then let's go to issues. And the first thing to do to have a look at what needs doing is to filter the labels based on the Array API and also to do. So what to do means is these are essentially issues which contain a to-do list, which then, the to-do list then is separate functions, for example, that we need to get into alignment, or for other cases it might be functions that we still need to implement, and so on. So these are kind of like top-level issues, which then can link to sub-issues, which are for specific functions and so on. And that's actually what this label single function is for, to essentially flag that the issue is for one function, and then to-do flags that it's kind of a top-level issue, which has a to-do list. So just for example, we can, let's go to the, let's go to the linear algebra extensions here, and we can see that, that there are all these functions here which need to be adhered to. So the approach that you should go through if you would like to help us to bring one of these methods into alignment with the standard is first, of course, you would need to sign in or sign up if you haven't got a GitHub. Then you would need to make a comment, which basically just lists the function that you would like to work on, and also then create an issue. I'm actually just going to very quickly open another window here, because I think this isn't showing in the correct formatting, most likely because we're not signed in. So I'm just going to quickly show on my own account as well. So yeah, I'm not sure exactly why that's the case, but that's okay. So let me just quickly bring this one over. So then we essentially have the issue created here, which then goes to an issue which is specific to the function. So if you would like to contribute, what you should actually do is write a comment. You should then make it a checklist, and then type the name. I'll actually just create a comment now and then delete it just to show you. So for example, if you wanted to work on the function tensor dot, you should, what you should first do is create an issue. So I will actually do that. I'll go through the process once and then delete it, why not? So you would type your issue tensor dot. You would actually then also give it these labels, which is array API, because that is what we're working on at the moment, and then also give it the label single function, because again, this is an issue that's specific to one function. And for now, let's just call it tensor dot. Let's submit the new issue. Okay, and then we have this tensor dot issue number 83. And then back in the comment, what we should actually do is then link the issue itself. So if we do number 83 here, you can see when we preview this, what we get is this. And then this is, this is exactly what you should comment. And then I'll do that now, like this, just for demonstration purposes. And then once you've made this comment, what I will do, because you're not able to edit this, because you're not part of the, well, presumably not part of the Ivy organization at the point of watching this video, so you're unable to actually edit this comment, but I'm able to edit it. So if I see this comment, and I'll keep regularly checking, I'll then just see this, and I'll then just edit this myself and bring it into the to-do list personally. So this is tensor dot should be replaced with 83. I'll then do this, and then update the comment, and then I'll also then just delete this, because essentially this is just a way of you telling me, hey, I'm going to work on this. I've created an issue, and this is kind of marking this as a function that I'm in the process of working on. And then this also means that when you come to such a to-do list and you see an issue has already been created, this is not something that you should try to work on yourself, because somebody's already working on it. Okay, so that's this process. And then once you've created this issue and you've given it the label array API and single function, we just leave that there. And then at the point at which only when your pull request has been accepted for the unit test for this function, should you then close this issue. Okay, so that's kind of how to flag that you're going to work on a function for others in the community to understand. Then I would say what the process would be. It would be you would make a fork of this. I've already made a fork in my personal repository. you would make a fork, you would then clone your own fork, not this one, you would clone your own fork, work in that fork locally using your IDE, get the unit tests passing, and then try to get the unit test passing for the particular function that you're working on. So we were working with TensorDot. So let's have a look in the tests, and you can see here that the folder test array API is a submodule linking to another repository, and this is linking to the official test suite from the array API standard. So if you click here, you'll see that it will go through directly to their repository. And yeah, we were looking for test TensorDot. So the function that we would need to get passing, linalg, I guess. Let's have a look. Yeah, so here it is. So this is the method that we'll need to get passing. And again, we'll be doing this in an entirely unmodified way because we're linking directly to the unmodified tests of the standard. So actually, let's just open an IDE just to see what this looks like a little bit in a bit more detail. Let's see if it opens Ivy. I guess that's the last thing I was working on. So let me make sure there's no local changes. No, good. Okay. So what we can do when we've got this opened up, and bear in mind when you clone this, you should also recursively, well actually recursively is not necessary, but you should also get submodules, because without cloning the submodule, you won't have this test array API folder, which you'll need. So when you're looking for a test, you can just do, I'm sure there's something similar in all IDEs, find in files. Let's bring this over to this window. Oh, I can't. Okay, oh. So then if we do like test tensor. It seems like there's only one, but I would then just make sure, because sometimes there's tests for special cases. So for example, if we go into here and we look special cases, and let's find in files tensor. And there's nothing found, so I guess there's no special case there. There are multiple references to tensor, but I think these just are wrapping around, certainly no more test tensor. So there's just this one method that we need to get fixing. I also assume that in special cases the functions start with test ACARs and then the special case goes afterwards. So I assume this is a consistent convention, which means that if we wanted to, we should have the special cases mentioned afterwards. So if you want to find all the methods that you need to get passing, you can just type test underscore method name, and you should then see all of the methods that you need to get passing. But just be wary of these special cases. And then another point to make, which is a general point, is that when you're doing your local development, actually the first point I'll make is that, in order to run these tests for different backends, it's necessary that the array module is updated. So here I have some uncommitted changes whereby I've imported Ivy as array module and then ivy.setFramework TensorFlow. And you'll need to do something like this in order to test any function for any given backend. So locally, you are unable to test all frameworks simultaneously. You're going to have to check them one at a time, and each time you test, you're going to have to change this to one of Torch, NumPy, JAX, or TensorFlow. And then the way we do this in the CI is pretty simple. We just, under test array API, we run the tests each time by setting this global environment variable. This is something that's not captured where I've modified it here. No, it is here, look. So by default, this array module is set to none. I've changed that here, but when you actually look, I can probably show you. when you look in here, you'll see that array module is none. And if array module is none, it checks this global environment variable, array API test module. So therefore, when doing the CI, we just set this environment variable to each of the specific backends and then run the tests accordingly. And also, we skip data types that are not supported in the framework. In this case, a lot of the uints above uint 8 are not supported by PyTorch, for example. So this is how we do it in CI. We effectively run 4 different instances of PyTest to check these 4 backends. We're not checking MXNet at the moment. We'll add support for that at a later stage, but there's been ongoing issues with getting MXNet running for various reasons, and we tend to spend probably 40% of our time, or even 50% sometimes, getting things working for MXNet, and then the other 50 for the others. So this is something we've just taken away from the CI for the time being, just to get us moving a bit more quickly. So now for running the tests locally, let's just take ABS. Let's find in files, test, and this is actually one that has lots of tests, but I'll just show you. And again, this is something actually, because there is also an ABS in general, so just to be more specific, let's make sure that we're looking only in test array API, because this is the only place that we should be thinking about for this first task. A lot of the methods in test IV are currently failing. A lot of the tests are recently failing because of some refactoring, and that's not a problem. Right now, we're just focused on getting these all passing. So let's find in here, test ABS, let's open the test, and then let's run it with the TensorFlow backend and see what happens. And they pass, that's great. And now let's run it for NumPy. And this is what your development will look like when you're trying to implement things and get them working. What about JAX? Works great. And what about Torch? And it works great. So this is effectively, as soon as this works, then this is effectively looking into how to run the test with different backends. You also will need to make sure that the code you've written is formatted correctly, and that will be explained a bit more in the next video, where I'll show you an example of how I am reformatting and reorganizing code, which is also important before making before your pull request will be accepted. But yeah, so this is just generally the process of how to kind of run the test locally that I'm focusing on here. Is there anything else should be said at this point? I don't think so. I mean, I can then probably show you one that's failing, because I'm sure many of them are failing. I mean, not that... Oh yeah, there's one point to make actually, which is general, which is that... that was passing. Which is that... so hypothesis failures, let me try and find one that fails. I'm sure, although these are quite simple, maybe some of these don't fail, but one point is that when the hypothesis module, which is a test package used in this suite of functions, this suite of tests, when they fail, they don't fail in the typical sense, and they log the results, they log the failure to terminal, which by default in PyCharm is not shown. So what you need to do is, I'm hopefully remembering off the top of my head, you need to go, I think it's advanced settings, and then it should be under tests. Yeah, here we go. So under advanced settings, under Python, and then tick PyTest, don't add no header, no summary queue. If this is unchecked, then you're not going to get a descriptive log to your screen when the tests fail, and you're not going to know why it's failing, because hypothesis gives you a lot of information using these summaries. So that's an important thing. Yeah, and I think that's enough for just the general process of running the tests and everything. So also you might have been able to tell that this was a cutaway to a future point in time, because the old intro was a bit out of date, and we've now changed the way we're doing things a bit. So Firstly, you might have come back to this video again and realized that it's quite different, and in which case it's supposed to be, we have changed the instructions a bit, and also you can probably see the date, it's about a week later than the other parts of the video. But I'm going to quickly now hand back to my former self just to wrap up the video. Thanks a lot. And the final point is basically just that, just as a bit of a warning, that the videos aren't carefully crafted and edited concise tutorials. I wanted to kind of show what the process looks like when going through and implementing this for the first time. So they are entirely unscripted. Essentially, what you see is me as I'm thinking through the problem and as I'm implementing the real commit without any preparation ahead of time. This means that sometimes there's a couple of minutes or so where I'm stuck and I'm thinking out loud and trying to work out how to do it. Well, for two reasons. First of all, it's quicker for me to do this than then spend lots of time editing. So that's a selfish reason. But also I think there is some positive there that, I mean, it's not realistic to see a 5-minute video condensing something that takes 30 minutes. And the intermediate processes of testing things and trying to work out what's going wrong is something that hopefully is useful as well, because it's very unlikely that you're gonna be able to fly through things in 5 minutes. So maybe some of the things that I'm doing to try to work out what's broken maybe are useful to you. Maybe actually I'm doing things in a very stupid way. I mean, you know, and actually could be doing things better, let's say at least, and that's absolutely fine. I'm very happy for you to leave a comment and say where I could be doing things better in my own workflow. I'm always happy to learn as well. But yeah, I just thought I would say, feel free to, you know, skip ahead a little bit if the videos are a bit long in places, but this is the reason why they are essentially done the way they're done. Okay, I think, so this one isn't too long, I should wrap up now. If you have any questions, please reach out on the Discord, which is on the README of the Ivy repository. Always very happy to answer questions there. Yeah, I hope you enjoy collaborating with us on Ivy. Thank you very much for watching this video, and I'll see you in the next one. Bye for now.